Hi, in this video I'm going to be solving exercise 6 from the final test previous year, 2018 January. In this problem we have a plus b and ab coprime numbers. If a plus b and ab coprime, then prove that a and b are coprime, or it's the proving the other way around. So a and b, of course, here I wrote it down. It's natural numbers. So if you want to solve this question, we need to use Bezout theorem, and it's beautiful. It's amazing. Let me type amazing here. Amazing. Amazing. Okay. 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 And where is my pen? Cool. And now let's continue. So Bezout theorem. So according to Bezout theorem, if we have, of course, natural numbers a and b, if they're coprime numbers, then there exists u and v, integer numbers, such that au plus bv is equal to 1. Or if we have this, if right side is correct, the left side is correct as well. So both sides works. I mean, if we have this, we can go to this side. If we have this, we can go to this side. You already know this. And then we're gonna be using this a few times, quite a few times in this problem. Okay, now let's go back to the question. So if we prove from left to right, so in this, because we have this, we need to prove both sides. Like the second step is from left to right, and then we try to prove from right to left. So left to right is easy. So let me write it. So what we have is a plus b and ab. They are coprime numbers. So based on that, we can have there exist u and v integers such that a plus b times u plus ab times v is equal to 1. This is my v. So this is my u, this is v. This is 1. Okay, I'm gonna move left a bit so that you can see my 1. Okay, so this is 1. And now the goal is, I'm gonna be writing it here. The goal is, because we want to prove a and b coprime numbers, we need to have a multiply, let's say, something m plus b multiply n something is equal to 1. So m, n, they are integer numbers. So this is the goal, because we're going to have left side of the Bezout theorem, and we can go to this one. And so the solution is very easy. So from this, we open the parentheses, the bracket, and I have au plus bu is plus abv is equal to 1. And in here, I have common factor b, and I take it out. So I have a times u plus b times u plus av equals 1. And here I'm gonna call this v prime, and I need to mention this is integer number. So I have au plus bv prime is equal to 1. From this, we can decide that a and b coprime numbers. So done. Yeah. Okay, now the third step is proving right to left. This is quite hard. So we have a and b coprime numbers. So based on this, we can have there exists, you need to write this on the test. There exists uv such that au plus bv is equal to 1. Okay, au plus bv is equal to 1. And now the goal is to have something like, a plus b times m plus ab times n is equal to 1, so that we can decide that a plus b and ab coprime numbers. On your final sheet, you don't need to write this. I'm just making it circle. It's just something that in our mind. This one, you don't need to type this. You don't need to write this on your, I mean, this and this would be enough. Because we have this, let's calculate the square of this. If you calculate square of this, you're going to have AU square plus 2AU BV plus BV square is equal to 1. Of course, you understand. Now we have A square U square plus B square V square plus 2AU BV is equal to 1. And now here I have AB here, right? And now I need to have A plus B right in here. So if I want to do that, it just comes from experience. You gotta focus. It's very important part. I'm gonna use my pen. You gotta focus in here. It's very important part. Okay, now I want to have, look, I have A square and U square. If I want to have A plus B, I need to have A, B, U square. You might ask why, because I need to add this and then subtract it. I'm just focusing on this one. I'm just focusing on this term, because if you focus in here, these two terms, if you take A and then U square out, inside you have here A plus here B. Do you understand? And then I do the same thing with this one. So I have B square and V square. And then I need to add BV square A. And then I need to subtract it. BV square A. I mean, you cancel this one and this one, this one and this one. You have this thing. So, and now I write plus this part. Plus 2AU BV equals 1. And now I continue. If you focus on this too, you take BV square out, and you have B plus A. And here AB U square plus, and this one, it's just minus. You can just write ABV square plus, this is 2AU BV. I'm not changing anything here. So, and now my goal is to take A plus B out of bracket. So AU square, and here plus BV square. And now here I can take AB out, minus AB goes out. So I'm using this too. Okay, AB goes out, and now U square plus V square plus. In here I'm gonna change it a bit. I'm gonna write AB 2 UV is equal to 1. Now A plus B times AU square plus BV square, and here I'm gonna take AB out, and I'm just plus AB, and let's write this one first. UV minus U square plus V square. I hope you understand this. I just did some calculation, manipulating it. And now I'm gonna call this one, let's say M, and I'm gonna call this one N. And this, both of them are integer. You need to mention this, it's integers. Why? Because UV integer, AV integer, so M and integer. So I have A plus B multiply M plus AB times N is equal to 1. From this we can decide that A plus B and AB, they are coprime numbers. Yeah, okay, that's done. So the most important part, I want you to mention this Bezout theorem at the beginning. This is the first step. Second step, you prove right to left or left to right, and then you do the next step, and then you finish. And then one part can be hard. Always this thing should be in mind. If you want to prove that A and B coprime, you need to have something like A times M, B times N is equal to 1. If you want to prove that A plus B and AB prime, you want to have A plus B times something plus AB times something is equal to 1, and then you can prove it. Okay, so this is the this is it. But before you before we finish, I'm gonna give you one example. So this example, let me focus a bit. So this is for you as a bonus. Oh, sorry. Okay, now you can see it. Cool. So this is exercise 3. This is exercise 3. No, exercise 2. So this is from TD test 2018 fall semester, Monday 3rd. So as you see, the first step is Bezout theorem. I'm gonna put my phone here. Okay, look, the first step mentioning Bezout theorem, and then second step proving left to right, and then in here it's quite different. So you need to have a and bc something, a times something plus bc times something is equal to 1, because you need to prove a and bc prime. Yeah, but on the third case, you need to prove right or left. So because here you need to prove a and c are coprime. It means that you need to have something like a times u plus c times something is equal to 1. And conclusion is important. So if you want to get full score 3 out of 3, or if you want to get this, like, yes, this is how they write it, you need to write in this way, and I'm sure you will get the full score. And then this is also a bonus for you. The last exercise, this is from TD test. I'll try to make a video for this, but it's just from numerical sequence. I hope you remember. So again, this is the correction. You can have it as correction. So 2 out of 2, and yes, maximum score. And then I'm gonna show you the next exercise 1 answer. So in exercise 1, you already remember it's a sequence. It's a question based on sequence, so you have to prove it's adjacent. So this is, of course, you can have it as correction, because it's a full score. They give this solution full score 2 out of 2. And yeah, you want to get yes, because if it's wrong, they will be like no, and it hurts, you know. So I'm gonna I'll focus the video a bit so that you can see it. Okay, now you can pause and then learn it. Okay, I hope it helped it. I'm sorry I can't show you the name of this person. So this is it, official ending. Good luck.